Hello and welcome to this lecture on PyTorch model training. There is actually a strong need to have this lecture because the process is, to be honest, quite confusing in PyTorch. Because we have so many different objects and it's not really clear which objects are impacted at which point and by what. So let's speak about it. So what do we have? We have the model, we have the optimizer, we have a loss function, we have a gradient update, then we have the backward function of our loss function, and we have the optimizer step. And then there are the model parameters. So many objects are floating around and it's not really clear which objects are changed and impacted at which point and by what. So it's really important to understand how everything interacts. And there is a very good article I would like to make yourself aware of. You can find the link down here and it's really worth reading. It helped me a lot to understand these things because they're not so simple. Alright, so basically we are having these objects. We are having the model, which is based on our submodule torch.nn. This one is including the layers, the activation functions and so on. Then we have the optimizer. And actually here we have the first issue because the model parameters need to be shared with the optimizer and we don't know how. And then we have the loss function. That one is used to calculate the losses. And all of these objects are basically feeding into the model parameters and the gradients. Here you can see the classical training loop. So this is a very typical structure that you can see a lot in our coding lectures. So we are having an outer loop for iterating over the different epochs. Then we have the inner loop in which we are iterating over the batches. And then we have at first the optimization. We are zeroing the gradients out. We will talk about that more in the later lectures. Then we have our forward pass in which we are calculating the predictions. Then we can take these predictions together with the true values and the loss function so that we get, taking all of this into account, so we get the losses. And then we have the backpropagation and the updating of the weights by calling optimizer.step. So this is basically the structure that you will see over and over again in our coding. And now we want to talk about all these little details in here. So the first one is optimizer.zeroGrad. This one is clearing the gradients. And for this you have to know that the optimizer is accumulating the gradients, and for every new pass, every new forward pass or backward pass, the gradients need to be deleted. But then the question is still, why is actually the optimizer holding the gradients and not the model itself? So let's talk about that later. We have our forward pass. In this step, the predictions are calculated. That one is very straightforward. We're taking data, putting it through the model and get back some predictions. Similarly for the loss calculation, also pretty straightforward. We have the true values, we have our predictions, and we have a loss function. All of that together is returning some actual calculated loss. And then we have the gradient calculation in this step when we call loss.backward. So this loss function object is calculating the gradients for all the nodes. And you can see here some example. We want to calculate the gradient of the weight 1. That is basically the partial derivative of the loss function with respect to this weight 1. And you have to know that the gradients are changed directly. So they are changed in place. And implicitly the model layers are used and the tensor gradients are updated. Then we have the weight update. So at this point you can assume that the gradients are known. Now we have to update the weights. And for this you can use the step function of the optimizer. That is the purpose of this function. And in this step the model parameters are updated, although the model was never called in this step. So also here there is some in-place functionality and things are changed in the backend, which is not really clear how it's done. So why is it done that way? What are the advantages and disadvantages? The advantage is that with the way the developers have set up PyTorch, they have created some very flexible and composable API, which can be used not just for deep learning, but also for other computational graphs. The disadvantage is a bit like what we have touched on in this lecture, that the model, the loss, the optimizer, they changed the parameter state and it's not really clear who is the owner at which step. Alright, I hope that this made it a bit clearer and you're now less confused than at the beginning of this lecture. Thank you and see you in the next one.